On this one, let's start with a simpler problem. For example, if you work for 2 hours at $10 per hour, how much money do you make? I think we can all agree that you make $20. How was that obtained? It was obtained by multiplying the number of hours by the pay rate. So we do the same thing over here. We take the number of hours that he worked as a tutor and multiply that by his pay rate. And the number of, or rather, the amount he makes per hour as a waiter multiplied by the number of hours he works as a waiter. They don't tell us how many, but they do give us enough information to say the number of hours he works as a waiter will be all the hours that he did work, except for the hours he worked as a tutor. So that gives us the money he earns as a tutor, and this gives us the money he earns as a waiter. Add them together, and this entire expression in green or orange or whatever color it is, because I'm colorblind, that is the answer. On this one, we do something similar. We have two types of coffee, type A and type B. We are looking for how many pounds of type A coffee were used. So let's say that X is number of pounds of type A coffee. So the price for type A coffee would be $4.15 per pound multiplied by the number of pounds. And the price that was paid for the type B coffee would be $5.85 for each pound of coffee multiplied by the number of pounds of coffee. The number of pounds of type B coffee is going to be twice as much as type A, so twice as much as X is 2X. And if we add all that up, that'll be the total amount of coffee that was purchased. So now we are ready to start solving for X. So 4.15X. And I need to multiply these two guys together. And get 11.7X. Now I can combine like terms for 15.85X is 332.85. And now divide both sides by 15.85, and X equals 21. 21 what? 21 pounds of coffee. That's a very good problem to make sure you understand how to do really well. So practice these really well. On this one, I see that we are talking about distance and speed and time. And so this looks like a job for dirt, the dirt equation. Distance equals rate times time, or speed multiplied by time. So I know the distance is 18.75 meters. So I will replace the D in the dirt equation with 18.75. I'm looking for the speed. or the rate, so I won't plug anything in for R. The time is 3 minutes, so I plug 3 in for T. Now I divide both sides by 3 and get 6.25 for R. But 6.25 what? What are the units? Well, to get R, we did 18.75 meters divided by 3 minutes. So it's meters over minute, or meters per minute. So this tortoise is moving 6¼ meters each minute. And incidentally, a meter is about a yard, just a little bit bigger than a yard. For this one, I think I'll shift gears and just use the author's explanation because he or she writes it out very well. At least I think so. So two trains are 416 miles apart, and they are going to leave at the exact same time and exactly toward each other. So how long will it take the two trains to meet? So on this one, we might do it this way. Well, one train is going 85 miles per hour, and the other is going 75 miles per hour. So we clearly need to use the dirt equation because we're talking about distances and speeds and times. But we're also talking about two different objects doing something. In this case, those objects are trains that are moving toward each other. So this table here is a very nice way to organize the information. So we have distance equals rate times time. And so this is the rate column, the time column, and the distance column for both trains. We know the rate of train number 1, it's 85 miles per hour, and 75 for train number 2. They both leave at the same time, and they're going to meet up at the same time. So whatever the time is for one of them, that'll be the same thing for the other. And to get these guys here, we recognize that they are distances. And distance is found by multiplying rate times time. So that's all that was done, was 85 times x and 75 times x. So now we can use that table, what we have there, to build some equations. We know that 85x and 75x are distances, the distances of the two trains. And those two distances are going to need to add up to 416 miles because that's what the problem said. And that's why we get this equation right here. So we add 85x and 75x and get 160x. Divide both sides by 160, and the trains are traveling for 2.6 hours. That's how long it takes them to meet. For this one, we are told that $20,000 is invested in company A and makes a 21% profit. In company B, $30,000 is invested and makes a profit of 12%. So what was the firm's total profit? Well, the profit from company A would be 12% of $20,000. And from company B, oh, wait a minute, that was 21% of $12,000, 21% of $20,000. Yikes. And 12% of the $30,000 from company B. So if I were to add these guys together, I would get $7,800 of profit. And that would be the answer to part A. For part B, what was the percent profit for their total investment? To get that, we would say they earned $7,800 profit from $50,000 invested, the $20,000 and the $30,000 together. When I divide those, I get 0.156 or 15.6% profit. So if this is a single year of investment, this is a very good return on investment. Now on this one, the author uses a table to help set up the equations to solve the problem. I'm not going to use a table, though the author's method is a very good one. But I'm going to show you an alternative that ends up being equivalent. So we have two solutions that we are mixing. Solution A is 60% alcohol, solution B is 10%. We're going to mix them, and the question is, how many milliliters of solution B is used if the resulting mixture is 40% alcohol? So we have this 60% alcohol solution. We mix it with a 10%, and by mixing the 60 with the 10, the 60 gets diluted down to a 40% solution. So we know that 60% of the 1,200 milliliters is alcohol. How much alcohol is in the 10%? Well, 10% of it, but they don't tell us how much there is, so I'll just call that X. Now, if I add up the amount of alcohol in solution A and the amount of alcohol in solution B, and that's going to end up being 40% solution, and 40% of the amount that we combined will be alcohol. The amount we combined was 1,200 milliliters and X milliliters. So 1,200 plus X. And that is the setup. Now, of course, we still need to finish, but this definitely helps. So multiplying, this right here becomes 720. And multiplying the 0.4 through the parentheses yields 480 plus 0.4x. I can subtract 0.4 from x from both sides to get the x's together. And then subtract 720 so that I get negative 0.3x equals negative 240. Upon dividing by negative 0.3, we get x equals 800, as in 800 milliliters. And that would be it.